Hello. So this video is on just an introduction to the idea of Lewis structures, which is actually the way that we show bonding in molecular substances, so things that have nonpolar and polar covalent bonds. So we're going to start off taking a look at something called electron dot or Lewis dot structures. They're a way for showing how the valence electrons get distributed around the central atom. As a way for us to predict how bonding is going to take place. So if you notice, oh, by the way, this organizer is page 411 of your binder. So make sure you have that out and ready to go. You can pause me and get that out if you don't have it out already. All right. So Lewis structures are a way to represent the valence electrons. So we're going to do one dot for every electron. And we're going to put them like on four sides or four corners, however you want to think of it, because we're going to follow Hund's rule, right? We're not going to pair up electrons until we have to. So for hydrogen, for example, it's got one valence electron, so we're going to put one dot. Does it matter where you put that dot? It does not. You can put it anywhere you want. If we move on to aluminum, it has three valence electrons, so we're going to put the three valence electrons on three different sides, and we're not going to pair them up yet. Oxygen, which has six, so we'll do four in four corners, and now we can start pairing them up. So 5, 6. So notice what I did there is I just kind of kept going around in a circle. So you want the paired orbitals to be adjacent to each other, not across from each other. It's going to help you when we start looking at shapes a little further down the road. And finally with neon, we've got 8 valence electrons, so neon would have the first 4, and then we're going to pair them up. So there's neon's 8 electrons. So once you know how to draw the Lewis structure, then you have to start predicting, okay, how are these atoms going to bond to other things? The easiest way to remember is that you're going to try and pair up all unpaired electrons. So for example, hydrogen will form one bond because it's got one unpaired electron. Aluminum will form 3 bonds, because remember, aluminum will bond on the rare occasion. It will form covalent bonds with hydrogen. Oxygen has 2 pairs, but 2 lone electrons, so oxygen will form 2 bonds. And then neon is completely filled up. Boy, that's a bad set of dots, isn't it? Neon's completely filled up, so it will not form any electrons, which makes sense because it's the noble gas. It's got a full valence of 8. Now, there are 3 rules that go along with these ideas, and you can memorize the 3 rules if you choose to. You're going to hear us refer to the octet rule frequently, so remembering that is not a bad idea. But the duet rule only applies to hydrogen and helium because you're working with elements that have electrons going into the first principal energy level. Well, the first principal energy level is only allowed 2 electrons, so duet 2. So that's why hydrogen only needs a duet. The octet rule applies to all your nonmetals. They are trying to get a noble gas configuration, and so they will try and get 8 electrons, share them if they need to between other atoms. And then finally, if you have metals forming covalent bonds, again, they don't do this except for when they are bonding with hydrogen and a couple other rare occasions. But you only have to pair up the unpaired electrons. So even though if you look at aluminum, aluminum has 3 of its own. If you pair it up, it only needs 6. So even though technically a full octet is 8, aluminum is satisfied when it forms covalent bonds to just have 6 electrons around it. But again, you don't have to memorize all these rules. You can predict the number of covalent bonds simply by counting the number of unpaired electrons. So you've got 2, and that's it. That's the idea that I want to go with. We're not going to start putting molecules together until we're in class together. So the 2 problem sets to do, one of them is to draw the actual Lewis dot structures, and then the other one is to predict how many bonds. So like I said, hydrogen with 1 unpaired electron will form 1 bond. Aluminum will form 3. Oxygen will form 2 because it has just 2 unpaired electrons there and there. And neon will form none because it has a full octet already. Okay, go do those 2 problem sets.